Hello, everybody. Welcome back. It's me, David Getzloff again. I'm just talking a little bit about Rust and uh, just how it works and maybe just a little bit about its memory model here. So here I've got a piece of Rust code. It's actually the Syracuse sequence. And to just start off, I'm going to run this bit of code for you, show you what it does. So cargo run, you can see that Rust, since it's compiled language, it's compiled, and then here we are running. And so we're asked for integer input. I'm going to do 5. And then we get the output as the Syracuse sequence. So 5, 16, 8, 4, 2, 1. So keeping in mind that's what this program does, we'll take a look at the code here. The top of the code here, function main, that's what executes when I do my run. In Rust, we have, since it's declarative based off these statements, but then it's also imperative since we've got all these sequences of statements here. And so we have these functions to break that up, break up responsibilities, but it's primarily imperative, and that's the code that I'm going to be showing you today. So we've got our function definition, opening, closing bracket. Here we've got some print statements that end with semicolons. Almost all Rust statements end with semicolons. And then they're kind of broken up by these curly braces. So then we have, after our prints, we've got an assign statement. So using let, and we let our input equal a new string. And so since Rust is statically typed, we have to let it know what the variable type is going to be. And so here it's a string. And we're also saying it's mutable, which means that throughout the program it can change. And so then here in these next couple lines, using the standard in and out, we're actually able to take what's in the standard in and out and assign it to that memory location of input, since it's mutable. And then we make a new mutable variable called next number, which is basically converting that string to 32-bit integer. So we can do some calculations on it. Then we're printing it out using the print statement again. The open and close curly braces inside the print statement basically mean, or it's going to fill it with whatever the variable value is. So you could do this. You could have a second one and a second variable and a third and so on. So after that, we've got our first control structure, that being the indefinite loop. You can see that we've got a while and then this condition. So while it's true, we'll execute what's inside this block of code. It's interesting that no parentheses are needed here around this condition. But yeah, this is a pre-test loop, both a half, or like a loop and a half, and the post-test loop you could do with a condition check and then a break statement to get out of this while. So very similar to what you do in Python. Then you have these other conditionals, the if. And so this if checks if next number is even. And if it is, then we're assigning a new value for next number, which is the result of running this half function on it. And otherwise, the new value of next number will be the result of this triple in one function. And then either way, we're going to print that output again, like you can see down here. So a couple things about that. If you want to do a 3 or more decision, you could use else if, and that'd look basically the same, just like this. So else if is the key for that, as opposed to like elif, which Python uses. Skipping over that part for now, we're going to look down here at our function declarations. So half, we have to say the value and the type that we're passing in, as well as then this arrow tells us what the output type is going to be for this function. So for both their i32, which stands for a 32-bit integer, and that can have a plus or minus sign attached to it. We're assigning it. This time, again, we're not using the mute because this half num doesn't need to change at all. So it's fine if we don't. And then to return, we just leave the semicolon off of this statement. So this is one of the cases where we actually don't need to have the semicolon at the end because that's how we return. These function statements can be placed here outside the main function or inside, although like all these other statements like the prints and the decisions, they all need to be inside some type of function. Rust doesn't have classes, but it does have structures. And so functions can be inside those structures as well. But structures cannot be like defined within structures. So that's kind of how nesting works in Rust. Finally, I'm just going to cover definite loops. This program didn't have any, but I do have one commented out here for reference. Basically, it's a for, just like any other language, for iterator in this range then. So from 0 up to 19, it excludes this 20. And that's just a little bit different than what you might normally see because it's just a integer dot dot and then another integer. Rust also has another primitive type called an array, which looks like this. So you could say let a equal, and then inside here, all these values must be the same type. So here they're all integers. And you could also iterate over this array since it knows to expect that whatever your iterator is going to be the same type object. That is my Syracuse sequence program. Just to talk a little bit about Rust's memory model, I'm going to come over here to this other file. And I'm going to run it for you. First of all, just taking a look at both these examples, you can see that from the outset, they look pretty much the same. You've got a foo, which is equal to a string, and then a bar, which we're saying is equal to foo. And then we're printing out both those values. So one might expect these to be pretty much the same. So I will run it quick. And as you can see, the value of bar is hello and the value of foo is hello. Okay, so cool. But if I run this again with part, for example, 2, you can actually see that we've run into an error. And so that is because of how Rust's memory model works. And so it doesn't really fit into either of those models that we talked to in class with the boxes or the sticky notes. But how Rust works is this foo points to the hello value, and then bar is going to point to that memory location as well. But what it actually does is, since we don't want to have 2 copies of it, because remember, we've got concurrency going on. You don't want to be having 2 references to the same thing. It makes a copy. But since in example 2 here, it can't make the copy because this string type, we could like add to this or subtract, do like a lot of the string operations, where on this one we cannot. Yeah, here bar just takes away the pointer from foo, and foo is no longer valid. So then here down at the bottom where we try to print foo, it's actually no longer pointing there. And this is to, when we do our concurrency, avoid like deleting, because we could delete foo and then foo would, or delete bar and then foo would no longer be valid. And so Rust just prevents us from doing that at all through its memory model. So I hope I haven't confused you too much there from that, but thank you for watching.